All right, next lesson we're looking at here is going to be about point slope form of a line. So looking at linear equations and how we can write equations in different forms, primarily focusing on point slope form today. So this warm-up says the contestant at a game show has already won a total of $2,750 when the game show was continued today. He earns an additional $250 for each question he answers correctly. So it wants us to write an equation for the situation, write a linear equation for the situation. So get my pen working here. What we have is a starting point, a starting value. So he has already won a total of $2,750. So we can call that our y-intercept. Remember, that's always our starting point. And he's earning an additional $250 each question. So he's got a slope of 250. So we can write that in slope-intercept form of y equals 250x plus 2,750. And then for the second one, we're going to estimate here our y-intercept. Looks like I'm going to say it's halfway between those two lines. Just for estimating purposes for this warm-up, we could get it exactly. We could calculate that. We'll get into that in this lesson, actually, but it looks like the lines on our grid are counting here on our coordinate plane at 10, 20, 30, 40. So going up by 10 each line. So that'd be halfway between 40 and 50. So that'd be 45. So a y-intercept of 45. And then if we count our slope, if we find 2 points, it's going down one line, so that'd be down 10, and then right 1, 2, because the x-axis is counting by 1, so 1 over 2. So down 10, right 2 would be a slope of 5. So we could write that in slope-intercept form. Y equals 5x, minus negative 5x. We're going down. I left off the negative. Let's change that. So minus 5x plus 45, starting value of 45. All right, moving on to the next page. It says Cyrus and Ava are pool cleaners who have been hired to drain the community pool. At the end of the summer, they are comparing rate at which the two pools drain. For each pool, write an equation to represent the linear relationship. So A, the city diving pool has a water level of 14 feet and drains at a rate of 3 feet per hour. So again, starting value 14, call that our y-intercept. Slope, it's draining, so it's going down 3 feet per hour. So we could say y equals negative 3x plus 14. For the second one, Bayside diving pool is at a water level of 15 feet after draining for 2 hours and 12 feet after draining for 4 hours. So we need to find slope using our slope formula between 2 points. So if we make 2 points from this, it's at a water level of 15 feet after draining for 2 hours. So 2 hours, it's at 15 feet. 4 hours, it's at 12 feet. So if we use our slope formula, y2 minus y1 over x2 minus x1. And that gives us negative 3 over 2 for our slope. Now, keeping that in mind, we got to work backwards. If we made a little table here to find our y-intercept, we got to go find for our y-intercept where x is 0. So we know where x is 2, we know where x is 4, and plugging in those y values, we can see the pattern here. Our y column is going down by 3, and it's counting by 2's on the x side. So if we count back by 2's to get to 0, we should go up by 3. So we got a starting value of 18. So we have our slope now, and we have our y-intercept of 18. So we can write an equation of y equals negative 3 over 2x plus 18. All right, the process for writing those two equations, let's asking about number 2. A little bit different because in A, we were given a slope and we were given a y-intercept, a starting value. Makes it much easier. We can write it straight into slope-intercept form. For b, we were just given 2 points. So we could see all the extra work we had to do to go back and find the y-intercept, first calculate slope, then go find the y-intercept to be able to write it in slope-intercept form. So what we're looking at today is being able to write an equation if we just have a point and then finding the slope. If we have a point and a slope, we can write it in point-slope form. All right, so point-slope form is derived from our slope formula. I'm trying to make this a little bigger here. So using our slope formula, the one we just used in that example on the last page, y2 minus y1 over x2 minus x1. If we first calculated slope, given 2 points, once we know our slope, we could then plug that in. And like it says, we could choose any point and plug those values in for our x1, y1, like it's showing here, and then plugging in our slope. And then looking at what we have left there, if we wanted to remove that x minus 2 from the denominator on the right side, what we would need to do, the opposite of divide, thinking of your inverse operation skills, would be to multiply by x minus 2. So we have to do that on both sides. So we end up with what this is showing right here. So we got our slope, and then parentheses, x minus the x value equals y minus the y value. Now, it's typically written or point slope form is written where that is flipped, where the y part of the equation is on the left side and looks like this. Okay, which leads us to having point slope form as described down here. Again, point slope form will always be given to you. That was just to show you where it's derived from. But it's just knowing how to plug in the numbers and use it. So it's y minus the y value of the point you're given equals the slope, and then parentheses, x minus the x value. Okay, if we know a point and we know a slope, we can put it in point slope form. So it says solve the equation in the worked example for y so that the linear equation is in slope-intercept form. What unique information does each form of the linear equation provide? How are they similar? How are they different? All right, well, if we want to take that equation from that example in point slope form and put it in slope intercept form, to get from point slope form to slope intercept form, we got 2 steps. Because what we're doing is solving for y. Step 1 is always going to be distribute. Y minus 6 equals, so that gives us negative 1/2 x, and negative 1/2 times negative 2 is positive 1. And then just trying to isolate the y, get the y by itself. So we're going to add 6. So we get y equals negative 1/2 x plus 7. So how are they similar? They both have the same slope. One's just written in the format where we can pick out the y-intercept. The other one's written in the format where we just know a point on the line. All right, so just some examples writing in point slope form. So number 2 here, they're giving us a slope, they're giving us a point. So here's our x1, y1, and here's our slope. Again, I'm going to write the format up here. And we can go plug those into our equation. So we'd have y minus 12 equals negative 8, and then x minus 3. So if you're given a slope and you're given a point, it goes very quickly. You can just plug it into your point slope form and you have your equation. 3 is a little more work. We got to find slope first using our slope formula. So x1, y1, x2, y2. So if we do y2 minus y1, so 836 minus 956 over 249 minus 429. So we're going to go subtract those, 836 minus 956, and we get negative 120. 249 minus 429 gives us negative 180. So if we want to reduce that, we can divide that and then use our calculator if we don't want to just reduce the fraction to turn it back to a fraction, and we're going to get positive 2/3. Remember, on the calculator, if you get a decimal answer, you can hit that math button and then enter on fraction, and it will reduce it into a fraction form back for you. All right, once we have the slope, we can pick a point. You can choose either point, it does not matter. Okay, whichever point, any point on the line would work to put it in point slope form and would be correct. I'm going to choose this first point. So my equation would be y minus 956, there's my y value, equals my slope, and then x minus 429. So there would be an equation. You would be correct to use the other point. If you use the other point, all that would change is this would be minus 836, and this would be minus 249 for the x. Other than that, slope would be staying the same. Okay, for the cost to ship a package in the mail includes basic shipping charge plus an additional cost per number of pounds of the package. A 3-pound package weighs $6.30. A 10-pound package weighs $14. So again, they're giving us 2 points. So we're going to have to find slope first. So the 2 points we'll be given is a 3-pound package costs $6.30 and a 10-pound package costs $14. So finding slope, y2 minus y1 over x2 minus x1. And we're going to subtract those. So 14 minus 630 gives us 7.7. 10 minus 7 gives us 3. So if we divide those, 7.7 divided by 3, we're going to get, lost track of my spot here, 2.566. Now, I'm going to see if we can convert that to a fraction, and it's 77 over 30. So there is our slope. And then we can go plug in a point. I'm going to choose that 1014 point. So y minus 14 equals 77 over 30 for our slope, and then parentheses x minus the x value, x minus 10. All right, for the next one, number 5, back to a little simpler one. We got a slope, we got a point. Here's our x1, y1, we can just go plug those in. So we'd have y minus 7 equals negative 3 over 8, and then x minus 50, and we got it. So you can see how much faster it goes when we have a slope and a point already given to us. We don't have to find slope. Last two, again, we're gonna have to find slope. For the number 6, the graph, I'm going to call this my x1, y1. I'm going to call this my x2, y2. So y2, 20 minus y1, 102. And then x2, 42 minus x1, 35. So if we subtract there, we're going to get negative 82 over 7. And if we divide that, and try to convert it back to a fraction, it cannot be reduced. So we're going to find that that is our slope. So we can take that slope, again, choose any point. I'm going to choose the point that is the 4220, and we can write it in point slope form. So it would be y minus 20 equals negative 82 over 7, and then x minus 42. All right, and then number 7, change colors just so it all can separate the problems easier. Again, finding slope first, just got 2 points. y2 minus y1 over x2 minus x1. So negative 8 minus 15 gives us negative 23, and negative 39 minus 7 gives us negative 46, and that can be reduced to 1/2. So there's our slope. Again, choose either point. I'm going to choose the negative 39, negative 8 point, so we can see something with signs here. I want to make a point of. So if I wrote that out, I'd have y minus negative 8 equals 1/2, and then x minus negative 39. Now, we know minus a negative turns into a plus, so we could rewrite that as y plus 8 equals 1/2, and then x plus 39. which leads to the point I wanted to make here. If the signs in the point are minus, are negatives, they're going to become a plus in the equation, and vice versa. If it's a plus, a positive in the point, the equation would be a minus. And that's simply because the equation is y minus the y value. So if you have a negative y value, it's going to turn into minus a negative and become plus. But a simpler way to kind of skip this step to get to our final answer is if it's a negative in the point, it's going to become a plus in the equation. All right, next one we got is a table. So first, finding slope from a table. Change in y there is 0. Change in x is 6. And 0 divided by anything, change in y divided by change in x is 0. So we're going to pick a point. I'm going to choose this point. So I'd have y, since y is negative 6, that's going to become plus 6 in the equation, equals 0, and then x minus 1. Now, this is leading to what we're going to get to here in just a minute with vertical and horizontal lines. If I distribute that 0, everything on the right side becomes 0. So all we're left with is y plus 6 equals 0. And if we now solve that for y, we're going to get negative 6. So the x has gone away, and we just have y equals negative 6, which makes sense looking at this table. What we have there is a horizontal line that's just going through negative 6 on the y-axis. The y value is always negative 6. So that has a slope of 0, and it's always going to be y equals negative 6. So 9, examine each detail about a linear relationship you may have been provided. Which form of equation do you prefer to use in each case? So you want to use slope and y-intercept. When you have a slope and y-intercept given to you. And remember, our y-intercept is just our initial value. If we're given some sort of initial value. If you have 2 points, works better to use point slope. We're just going to have to find slope, and then we can choose a point, but you won't have to work backwards and go back and find the y-intercept. And then C, slope and a point other than the y-intercept, again, is going to be easiest to use point slope. You're going to use what we're given to try to put it in as little work as possible to write our linear equation. All right, so I told you just a minute ago we were going to get to horizontal and vertical lines. That's what we're looking at now. So first, consider that equation that from our last page we were just looking at, y equals negative 6, that we wrote from that table. How is the equation different from the other equations? What is the slope? So again, the slope was 0, and there is no x. Okay, so what happens is the x went away because the slope was 0. When we distribute the 0, all we're left with is y equals whatever the y value is. So B, describe the graph of the coordinate pairs in this table. It created a horizontal line. And C, explain why the equation makes sense in terms of the graph. So if the equation was y equals negative 6, and we're thinking of a horizontal line through negative 6, again looking like this, that value is always negative 6. The y is always going to be equal to negative 6 no matter which x we put into it. So it doesn't matter what the x is, the y is always going to be negative 6. Okay, another similar example. 2, write an equation of each linear relationship. Describe the graph of the linear relationship. So again, A is just like that one we saw. If we see the y values are all the same, we can save ourselves some time and cut straight to writing the equation as y equals whatever that y value is. We know the y is equal to 11, so at every point, so we have a horizontal line going through 11. Okay, similar on B. If you notice on B, the y values are the same. If the y values are the same, we have a slope of 0. You could use your slope formula there and calculate that. But if you recognize the y values are both the same, that means we have a slope of 0. So we can go straight to writing our equation as y equals whatever that y value is. Now, if you didn't notice that and you tried to find slope, then you would realize it's 0. So you might do a little extra work, but you're eventually going to get to that same point. All right, for the next page, now we're going to look at the opposite of that. We're going to look at horizontal lines. So explain how this table is similar to and different from the tables in question 1 and 2. So we still have a value that's remaining the same. This time the x's are all the same. The y's are different. So it's basically the opposite of what we just saw. This equation is going to be x equals -2. So what this is we have a vertical line where the x value is always -2. Now, the slope of a vertical line is going to be undefined. C, we just described the graph, already drew that. D, use the slope formula to calculate the slope between 2 points in the table. So we'll do it once, but again, if you recognize those x's are the same, that's going to be an undefined slope. So if I choose change in y, that's up 9. Change in x is up 0. So the reason why our slope is undefined is change in y divided by change in x, you can't divide by 0, so it is undefined. In E, what is the y-intercept of this linear relationship? Well, there is no y-intercept. It's never going to cross the y-axis. All right, 4, write an equation for each linear relationship. So just recognizing which value is the same here. So for A, the x value is the same. So that equation is just going to be x equals 17/2. It'd be a vertical line going through 17/2. Similar to B, you'll notice the x values are the same. So that equation would just be x equals -7. Another vertical line, this time going through -7. And C, create an additional table of values and write an equation of a vertical line. So you could create any table you want here, as long as the x's are all the same. I'll just make them all 1s. Doesn't matter what the y's are really. And the equation would just be x equals whatever that x value is. Okay, so horizontal line, y's are all the same. Vertical line, x's are all the same. All right, it says carefully cut out the graphs tables at the end. Again, if you're doing this digitally, you can't cut them out, but you can at least look at them and match them. If you go to the very end of the lesson, you're going to find the graphs and then the equations that go with it. Now, I'm going to tell you, I'd take a moment and pause the video and see if you can go through those and match those. And then I'm going to, you can unpause it, and I'm going to give you the solutions here so you can check your work based on those. And then we'll be going over those in class. All right, so for A, if you've paused and tried it now, it would match up, the graph A would match up with the equation y minus 200 equals -5, and then x minus 24. Graph B would match up to the equation y equals 1/2 x plus 40. Graph C would match up to the equation y minus x equals 2. Graph D would match up to the equation y equals -3/4 x plus 33/2. And then graph E would match up to the equation y equals 8x plus 120. And then graph F would match up to the equation y equals 1.2x plus 9. Okay, so you can use that to check to make sure you match those correctly. Again, comparing those graphs, how are they different? How are these differences reflected in slope-intercept form of the equation? Couple varying answers you could put here. One of the graphs goes down from left to right, one goes up from left to right. The graph that goes down from left to right has negative slopes. Graphs that are going up from left to right have positive slopes. Being able to identify y-intercept in some of the equations, some of the other ones haven't defined the y-intercept depending on it is, so lots of varying answers we could put there. So I'm going to just leave those blank and let you fill in based on your observations. Same thing here for number 3. It says analyze the equation for each table, determine the coefficient for x in each one. Okay, so again, you could plug in whatever you recognize here. For instance, I'll just give you one example, like table D. Using our slope formula, you'd have 9 minus 15 over 10 minus 2 equals, and you could subtract that and get negative 6 over 8, which reduces to be negative 3/4. So that'd be your slope, which would be your coefficient of x. Remember, thinking of slope-intercept form, the coefficient of x is always our slope. Okay, so you could check that with each equation, see what conclusions you come to. Same with B and 4. How can the number that is added in each equation written in slope-intercept form be determined from the table? And then 4, analyze the equation for each context, explain each term of the equation and what each one means. So just analyzing those graphs, making your observations, and again, that's what we will discuss in class. All right, wrapping up here, talk the talk. Say what you've learned about two forms of a linear equation. Slope-intercept form, we need a slope and a y-intercept. Point-slope form, we need a slope and a point we're given. What information can you determine about each line by looking at the structure of the equation? So A is in slope-intercept form. So we can recognize that we have a slope of 3/5, and we got a y-intercept of -4. B is in point-slope form, so we can recognize we have a slope of 2. And then remember with the point, it's the opposite of the sign in the equation. So if it says x plus 1, x was -1, and if it says y minus 6, y was +6. C, in the form it's written, we can only initially recognize slope, but if we solve for y, then we are in slope-intercept form, and we have a slope of 2 and a y-intercept of -4. So one step could get us into a form where we could pick out slope and y-intercept. For D, it is solved for y, so it's in slope-intercept form. We got -2/7 for our slope, and there's nothing written here, so that means it's like having a +0. Our y-intercept is 0. And then for E, back to point-slope form, so your slope there is -1. There's a negative sign out front, and our point, if it's x minus 4, x is +4. Y plus 5 means y is -5. And then for F, y equals 19. So if you remember back to the pages about horizontal and vertical lines, that is a horizontal line. So that has a slope of 0. And since it's a y equals, it does have a y-intercept of 19. It's going to go through the y-axis at 19. Okay, 2, create a context that represents a linear relationship that passes to the point 256 and has an increasing slope. Then write the equation in both forms. So increasing slope just means we need to have a positive slope. So I'm going to create a slope of, let's say, 2. So if we write this in point slope form first, we got y minus 56 equals 2, and then x minus 2. And if we want to change that to slope-intercept, we got 2 steps. Again, we got to distribute. We're solving for y is what we're doing to put it in slope-intercept form. So 2x minus 4. And then we'd have to add 56. So it gives us y equals 2x plus 52. So we know we have a slope of 2 and a y-intercept of 52.